Right, hi there, and welcome to the first video of the recurrence relation topics at Higher Maths. We're just going to have a quick introduction into the recurrence relation topic, which is something very closely related to sequences and percentage problems. Okay, so three things we want to be able to do in this video. First one is to be able to create a recurrence relation from a given context, to be able to find the subsequent value of a sequence from a given term of the sequence, and then lastly being able to identify a number of iterations of sequence to reach a given value. Now the first success criteria there is essentially the big one, being able to create a recurrence relation from a context, and the next two are being able to use a recurrence relation. Okay, so I'm going to give you a challenge question. Anybody loves you very much, gives you £1,000 for your 16th birthday and promises to give you £500 on each of your subsequent birthday, provided that all monies are invested in a bank account paying 3% per annum. How much will you have on your 21st birthday? Okay, take a couple of minutes and answer that question for me, please. Okay, so firstly, on your 16th birthday, here, you're going to have £1,000. Okay, now the difference between your percentage problem here and your percentage problem in the National 5 is that something else has been added each year. Okay, that £500 there. Okay, so to find out what you have on your 17th birthday, you're going to have to do your interest calculation. So you're going to take your £1,000 and you're going to multiply it by 1.03 for the 3% being added. Okay, but then on your 17th birthday, you're also going to get an extra £500. Okay, so now that ends up working being £1,530. Okay, now same going to happen again the next year. Okay, your 18th birthday, that £1,530 you put in at the start of your 17th birthday, or you had in the 17th birthday, is going to get 3% interest, and then you're going to add on an extra £500. Okay, which gives you £2,075.90. Okay, and then the same thing's going to happen the next year. At your 19th birthday, what was in at the start of the year, that £2,075.90 is going to get 3% interest added, and then you're going to have an extra £500. So when you go through that process, just to the end there, sorry, I just skipped ahead a wee bit. You can see that you're doing the same thing every year. You're times it by 1.03, but you're adding on an extra 500. Now that's the difference here between a recurrence relation or a percentage question at higher and a percentage question National 5 is because you've got that £500 being added. Your total's changing every year. You can't do it in one sum, but you are doing a repeated sum. You're doing the same thing again and again, which is why we call it a recurrence relation. Okay, so what I'm going to do is we're going to turn this in, and instead of looking at it as numbers, we're going to put a little bit of notation in here. Okay, so give me a second, sorry, just to sort this out. Okay, so instead of looking at numbers, we're going to put a little bit of notation here. So instead of having it as just a repeat sum, I'm going to put a little bit of notation here that you won't have seen before. Now, recurrence relation, you know every time is doing times 1.03 plus 500. So we're going to call each term in the sequence a UN term. So a number in the sequence is UN. So like U1 would be the first number in the sequence, U2 would be the second number in the sequence, U3 would be the first number in the sequence. Okay, and to get the next number in the sequence, UN plus 1, we're going to do 1.03 times UN, and then we add on 500. Okay, now you can see there, that is the sums that we're doing. We're times by 1.03, we're adding on 500. This is just the notation we attach to it. Okay, so your U with a subscript 1, 2, 3, 4, 5, 6, 7, so on. That's the number of terms in the sequence. So we could look at it as this here, the starting value we tend to call U0. Before any time passes, that's your first one. This would be U1 is equal to 1.03 times U0. So that'd be 1.03 times U0 add 500. That gives us U1. Okay, then to get U2 here, it'd be 1.03 times U1 plus 500, and so on and so forth. Okay, so you can see this recurrent relation defining the sequence, just the next one in the sequence. To get the next number, you need to do 1.03 times the number you have and then add 500. Okay, so that is a recurrence relation, and then this process here is actually using the recurrence relation. Okay, so I'm going to give you another question now. Okay, Auntie Betty, still there, lives on a farm, infested with bunnies. She decides that she had had enough of them eating her crops and decided to start an eradication program. She estimates there are initially 2,000 bunnies. during each month, she aims to kill 80% of the rabbits present. But then bunnies being bunnies, each month another 100 invade Annie Betty's farm. Okay, both these examples came from a Mr. Colleen at Bill Baxter. By the way, just I enjoyed both these examples. So give that a retry. Try and write your reconciliation, and then run through it for your bunnies after 4 months. Okay. Right. So firstly, you can see the things that are happening here. The two things that are going to contribute to reconciliation are the two things that keep happening again and again and again. So that 2000, that is only there at the start. That's the only time that number is going to be there. So that's not part of your actual reconciliation. The two things that repeats is that 80% of the rabbits are killed each month, but then 100 come back every month as well. So if I'm killing off 80% of the pests, that's leaving me with 20%. So I know I'm going to have to find 20% of what's there, but then another 100 is going to come in. So your reconciliation is to get the next number in the sequence, which is your UN plus 1, is going to be 20% of what's there at the start of the month, but then an extra 100 come in. So that's your reconciliation. Okay, so your U naught right at the very start is 2000. Okay, that's the only time it's 2000 there. To get U1, we're going to do 0.2 multiplied by 2000, add on another 100. Okay, so 0.2 of 2000 is 200, add another 100 is 300 rabbits after that first month. Okay, U2 is going to be exactly the same. It's 0.2 times 300, add another 100. Okay, so that's 30, 60, 160 there. Okay, and then in the exam, to be honest, I think one or two of them would be enough to show you know how you're doing with your reconciliation. Your U3, you would then sub in 160. Okay, add on, that's 132. And then after 4 months, okay, 126 rabbits there. Okay, so that's how many they did after 4 months. Now, that's the first two parts of your reconciliation, your success criteria we're talking about. Firstly, being able to write a reconciliation from a context, and they'll change. You'll definitely like we do like talking about bacteria or stuff killing or stuff or money going up. That's kind of your two favorite examples. And then this here is being able to run through that reconciliation. Okay, now lastly, we're not looking at it in context here. Looking at just being given a reconciliation, UN plus 1 is equal to 0.7 UN plus 5, or U naught is equal to 6. Okay, and just we've been asked to calculate the value of U3, so prove that you can work a reconciliation and then find the smallest value of UN for which UN is greater than 16. Okay, so firstly, we've got a reconciliation there. Okay, it's telling us that U naught is equal to 6. So U1 is going to be 0.7 times 6, add 5. Okay, this is where this is where it falls down. Like this is where it falls down compared to the National 5 stuff. We can't just do it in one sum. We've got to actually run through the sequence. Okay, so that's, excuse me, sorry. Just had a wee problem with my computer. So 0.7 times 6 is 4.2, add 5 is 9.2. And then your U2, I would just jump into it. You've shown you can use your reconciliation 9.2. Maybe do one more for one more, and then you can just put the answers after that. Okay, so U2 is 11.44, and then you just can jump in and do U3 times by 0.7, add 5. Okay, it's 13.08. Okay, so that's your first part answered. 13.008, sorry. Okay, now that's your first part of the question. The second one is find the value of n for which un is greater than 16. Now, essentially, that means how many times do you have to run through this equation before we get over 16? And that's simply just going through your U4, U5, U6, and finding out what one is above 16. Now, what I would just encourage is, particularly the guys with the Casio, the good Casio calculators, get your teacher to show you how to do that quickly. Okay, it's just a case of setting up a reconciliation using the answer key and then rattling through it. Okay, so I'm just going to do a bit of work here and jump to it. Okay, now when you run through that, U6, U7 are still under 16. So U8 is the first one that goes above that 16.05. It goes above that 16 at 16.05. So n is equal to 16. Sorry, n is equal to 8 for the smallest value that goes over 16. Okay, now going to success criteria, 3 things you need to be able to do. Create a reconciliation for a given context. Now that can be just we're looking at there, just it will be a story, you'll recognise them very easily. The one thing I would say when you're looking at that is make sure that if you're writing the recurrence relation, you're looking for the numbers that you're given that repeat. Okay, that happens every month or every week or every year. The two things that will be there will make up your recurrence relation. The second and third thing, I've been able to use that recurrence relation. So being able to use U0 to find U1, being able to use U2 to find U3. Okay, and then lastly, just a kind of wee niche one, identify the number of iterations of sequence to reach a given value. Okay, thanks for listening.